So we've been talking about cognitive load theory and working memory being crucial. Normally when people deadlock and really cannot understand or cannot achieve something, a good thing to look at is what is the working memory limits? Have people gone over the 7? Because it's often an explanation of why people deadlock at any task. A prime example, I've spent a lot of time helping people learn how to write essays or reports. And often people just can't do it. I keep saying, what's your structure? What's your big plan? They just can't write it. And I think this is a working memory constraint. People are trying to figure out how to write a particular sentence, which words to go where, and that's occupying most of their working memory. But then the sentence has to fit into the paragraph. How does the sentence fit into the paragraph? That's even more working memory. And then how does the paragraph fit into the overall structure? Especially if you're writing a novel, you might have different characters. How does it advance the personality of this character or the plot of that character? There's so much to keep in track. Writers use a lot of tools to do this. They have detailed plans. They have software like Scrivener, which allows people to keep track of multiple items, all ways to keep it within the working memory limit so that when you write that paragraph, you know how it's going to fit in. It's very hard. Again, the solution is chunking. If you get better and more practice, you might be able to write the paragraph more automatically, which means you can focus more on big things like how it fits in. Computer programming is another example where there is a lot of evidence that working memory makes a huge difference. When you're trying to write a line of computer code, you first of all have to figure the syntax. Now, is it a double colon or a single colon here? Do I put a curly bracket or a square bracket? What do I call that variable again? Is it X or R? So you're thinking a lot of your working memory is used up trying to understand that line of your code. But then you've also got to think about how does that fit into the overall thing? What am I trying to do in the subroutine? How does the subroutine fit in the big picture? Which variables is it changing? How does it advance the overall goal? So you're trying to think about small scale things and middle scale things and big scale things, and it becomes overwhelming. So there's some evidence that the best computer programmers, in many fields the best people are maybe 3 times better than the average. In computer programming, the best people are maybe 10 or 100 times better, in the sense they can get 10 or 100 times more useful, good code written in the time. And a lot of that's to do with the people having very big working memory, plus good techniques like chunking and external sources to help them work around their constraints. But now let's talk about how this whole concept of cognitive load theory and working memory is relevant to communication. When you communicate to people, normally you want to be understood. Unless, of course, you're trying to write a dense legal terms and conditions document which you don't want people to understand, in which case, go big time on the cognitive load. We can divide cognitive load into 3 components, as intrinsic, extraneous, and germane. Now, intrinsic cognitive load is what you absolutely need to understand something. It'll be high for some topics like quantum mechanics and low for others like how to make a peanut butter sandwich, but there's a certain amount of cognitive load intrinsic to whatever you're teaching. Can't do anything about that. But then there's extraneous cognitive load. This is the extra cognitive load you impose by badly structuring your writing or your presentation. You can easily force a student to work much harder than they need to, or the listener or the reader, by bad structuring. And that's relevant, first of all, because if you have too much extraneous cognitive load, plus the intrinsic can push them over the 7 plus or minus 2, in which case they just cannot understand what you're doing about no matter how many times they read it. You've probably all been in that situation. I just can't understand this. I've read it 15 times, it still doesn't make sense. That's almost certainly because the combination of extraneous cognitive load and intrinsic cognitive load has gone over your capacity. But it's worse than that. Even if you stay under your capacity, there's a third good form of cognitive load called germane cognitive load. If you've got some spare slots in your working memory, you can use them to think of things like, oh, this is a bit like what I learned about the other day, or I can think of a new place we could use this, or gosh, that person's clever, I should give them a job. So you really want to have the cognitive load of someone understanding what you read or what you say to be as low as possible, so you free up some slots so they can use it to think about the context and other situations where they've seen it. So it's crucial to reduce extraneous cognitive load. We want to make sure that the cognitive load that someone has to understand what you're talking about is the absolute minimum you can to master the concept, and don't, by bad choices, give them more. A classic example is using acronyms or definitions. I've seen many documents that start with a list of definitions or acronyms. What are you going to do with them? Memorize them all so that when you come to those words later off in the text, you can say, oh yes, I remember that. If you're memorizing a list of 10 definitions, that's your working memory gone right there. You should structure your presentation so that people can focus on one thing at a time without having to remember things scattered somewhere else earlier or later. Now here's an example. I asked ChatGPT to give me a document, first of all in a form that's bad for your working memory, and second in a form that's very good. So here's the form that's bad. Defining cloud computing. Now you can pause and read this. Cloud computing is a paradigm that involves the delivery of various services through the internet encompassing servers, storage, databases, networking, software, analytics and intelligence. Pretty unreadable. Pause and have a look, but it's pretty unreadable. Here's a second paragraph of the same thing. The IaaS model provides a virtualized blah, 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 blah. This is full of jargon. Here we're talking about IaaS, PaaS. What are those? Well, it's defined them here, but that meant you had to remember what they were from this slide to the next slide. If you don't, you're either lost or you have to go back. Either way, more slots of working memory. But it's worse than that. We're using long, complicated words, encompassing, paradigm. Now, for some people, maybe they know immediately what this means. Most people don't. These are words they have to think about. Oh, what does paradigm mean? How is it relevant to this? Once again, that slowed them down. They've stopped to focus on that, or maybe there isn't time, and they just, I don't care what it means. Or it's used up some of their working memory. Also, the sentences are long and dense. There's half a paragraph in one sentence here. Whenever your brain is processing a sentence, you have to keep it all in your brain at one time. The beginning, the middle and the end. Especially in languages where the verb comes at the end, like German. I will to the school go. You don't know what you're doing with the school till you get to the end. When you get to the end, go. Okay, where am I going? You have to go back and remember to the school. So a complicated sentence, depending on the structure, occupies a fair bit of your working memory just to comprehend it. So the longer the sentences, the worse it is. And what are you doing here? Service models in cloud computing. What's the goal? Someone's probably also thinking, where are they going with this? What are they trying to explain to me? Why are they covering all this? So that's occupying more slots in your working memory. So something like this is very heavy on your working memory, just to understand the long sentences, to the long words, remember the acronyms. There's a lot going on, which means you don't have much left to understand. Why is cloud computing important? Should we invest in cloud computing? Now here, once again, thanks to ChatGPT, is the same thing rewritten to minimize cognitive load. So cloud computing means using the internet to access servers, storage and applications instead of having them on your computer. It's like renting services online when you need them, whether it's for storing files, running apps or managing data. First of all, it's half the length. The sentences are short. Each sentence is only 2 lines. They're using simple, straightforward words. Much, much easier to read than this. This says the same thing, but which of the two would you understand more easily? Here's a second slide. So now we're revamping what this was. There are 3 types of cloud services. 1, 2, 3. So first of all, the definition is used in the same place as the explanation. So you don't have to suddenly jump backwards and forwards. You're spelling things out when you use them. It's not every time they use them. Simple language. And you're flagging what you're doing using bullet points. People can see right away, okay, we're going to explain what these 3 things are, and here they are, and there are 3 things. Whereas if you go back to this, how many things are there? What are we trying to do? Are we trying to define them? People don't know what's going on, so they're going to be using some part of their working memory worrying about where are we going here, how many of these things are there. So by making all that very plain and basic, it becomes much easier to read. So the bad example, long, dense sentences and paragraphs, fancy words, jargons, acronyms, long lists with no pointers to which bits are important. Good example, simple, plain language, short sentences, short bullet points focusing on key issues, lots of signing to tell you where we're going. A classic example of good and bad cognitive load is interpreting diagrams. Here's a diagram you might see in a scientific paper, and this is how scientific papers often force you to present these things, which is very bad. So we've got a diagram, and below it is the caption. So if you want to understand the diagram, i.e. what's the red line, what's the blue line, you have to go down to the caption. Remember, okay, red is the temperature in the lower stratosphere. Then jump up, okay, that's lower stratosphere. How about the blue, what's that? Oh, jump down. So every time your attention goes from the caption to the text, you have to remember something, so slots of your working memory are being used up. Then this whole thing's called figure 7, and figure 7 is referred to somewhere in the text. What this means is, might be a different page in the text. You get to this and it's coming an argument, if observed global warming is caused by this, then figure 7 shows something different. You might then have to flick back to figure 7, which might be on a different page, and remember, what were you asking this to show? So to understand this diagram, you have to store a lot of memory as you go to the text and back and to the caption and back, which is all wasting slots on extraneous that could be better used for more important things. So the better approach is the infographic. Now, this is not a course on infographics. There are many courses on good infographics up there. If you have to produce them, check this out. What I want to tell you is why they're important. Here, what I've done is taken the same information and put it all in one graphic. So the question, the world's surface is heating up, but is this caused by the sun or by the greenhouse effect? Then you've got the diagram. You're actually now explaining what the things are in the diagram rather than a separate caption. And then it's showing the temperature in the lower atmosphere is going up, but the temperature in the upper atmosphere is going down. So this is telling you what you should look for here. What you should look at is the red line is going down and the blue line is going up. Only the greenhouse effect can explain this. So everything you need to get the key point out of the diagram is right there in the diagram. Makes it much easier to understand. Another example is in teaching people how to solve maths and physics problems. When people are a novice, you shouldn't set them problems, you should set worked examples. You've probably all seen this. I don't know how to do this. A worked example is really handy. Physics lecturers often like to think the best way to get someone to learn something is make them active, to actually give them problems to solve. But actually the research shows that is the best way when they're quite good at something, but when they're a novice, the best way is to show them worked examples, maybe even a video of someone else solving it. The reason is that a question like this one, which we did back in week 1, can be overwhelming. How many oil trucks transport energy as fast? What does it mean to transmit? What do we mean by energy? Is that different from power and work? What units are we using? How do you go about doing this? There are lots of things to think about, which makes it overwhelming. How do I convert the units? Whereas a worked example, power of a transmission line. Here we have 3 steps where we convert the power from megawatts into megajoules per second, or watts. And so a reader can just spend all their time focusing just on this one step. How do we go from there to there without worrying about the big picture? So they can look at each step and understand that, and then once those are understood, try combining them to understand the overall structure of the entire argument. Of course, once you're an expert, you don't want this. You actually want to solve problems, because no one's going to give you a job reading worked examples. You have to actually solve problems. This is called, generally in education, scaffolding. Scaffolding means building a scaffold to help people when they're novices by allowing them to focus their working memory on just one part of the problem and not another. And then slowly you take the scaffold away as they automate, as they chunk the basic skills. The best example, if you want to see this done right, is computer games tutorials. A computer game company has to, for a complicated like a strategy computer game or a role-playing game, has to get you up to speed. And they do this with tutorials, and the tutorials very carefully introduce one new function or task at a time, and you practice just enough until it's become automatic, and then they introduce the next one. They have to do it at just the right rate so it stays interesting. You don't have like 14 hours of memorizing commands. That it's fun while you're doing it, but that it has to be gentle. If you introduce too many things at once, people get baffled and give up on the game. So a computer game company will spend a huge amount of time and resources and effort doing this right. I wish we could do the same for education. We had the same resources. So key points from cognitive load theory. If you put too high a cognitive load on your readers, you will not be understood. So it's really important to think about this. Worse still, if you've got a heavy extraneous cognitive load, they'll be so busy trying to figure things out, they won't have time to think about the implications, how it fits into the big picture and so on. So try very hard to minimize all extraneous cognitive load so they can focus on your crucial argument.